Hi everyone, we are going to be starting packet number 13 and talking about systems of linear equations. So this idea or system of equations is a set of two or more equations with the same variable. So if you notice in this example, the top equation has an x and the bottom equation has an x, and then the top equation also has a y and the bottom equation has a y. So since they have the same variables, we call them a system. A solution to a system of equations is where the lines share points. So if I were to think about this and I were to graph those two lines, we would say that where they share points is where those two lines cross. So it asks us, where do you think the solution to a system of linear equations would be if we were to graph them? It's where the line crosses. Or I should say where the lines cross. Okay, so when we talk about that, it's going to be one single point. Think about when two lines cross, their intersection right here is going to be our solution. Depending on where they cross, we can find that ordered pair. So given this system, x minus y equals -3 and 2x plus y equals 6, we want to know, is 2, 5 a solution to the system? In order for it to be a solution to the system, it has to make both equations true. So what we're going to do is we're going to substitute in 2 for our x values and 5 for our y values. So if I take x minus y equals -3, they're doing that problem right here, x minus y equals -3. If we substitute in 2 for the x and 5 for our y, we're going to see if it solves true. 2 minus 5 is -3, which we had said it was equal to -3, so it's true, it checks out. When I go to do my second equation, which is 2x plus y equals 6, again, we're plugging in 2 for x and 5 for y. 2 times 2 is going to be 4. 4 plus 5 is 9. 9 does not equal 6. It's false. So this is not true. It's not a solution. Let's try this now if we were to use 1, 4. So in this case, our x is going to be 1 and our y is going to be 4. So I'm going to take my first equation, x minus y equals -3, and I'm going to substitute in. We're substituting in 1 for x and 4 for y. And we want to know, does it equal -3? 1 minus 4 is -3. So these equal out. So it's true for the first statement. We've got to make sure that it's true for the second equation. 2x plus y equals 6. Anywhere I see x, I'm putting in that 1. Anywhere I see y, I'm putting in 4. And we want to know, does it equal 6? 2 times 1 is 2. 2 plus 4 is going to equal our 6. So it checks out. So yes, 1, 4 is a solution to the system. Is the solution to the system. And if we think about those two lines crossing, they're only going to cross in one place. So that 1, 4 is going to be the only place that they cross, and that's the only solution to that system. We're going to have three methods to solve a system of linear equations: graphing, elimination method, and substitution method. We're going to use the graphing method today. And so the graphing method, we're going to just take what we've been doing graphing, and we're going to, instead of graphing one equation on a graph, we're going to graph two equations. When we look at that, there are three types of solutions. One type of solution is when there is one solution. The two lines will cross only in one location. What is true about these is that they're going to have different slopes. Whoops, that's not what I wanted. They're going to have different slopes, and they're going to intersect at one point. If we look at the second type of solution, it says no solution. They have the same slopes, but different y-intercepts. Those two lines will travel at the same rate, and they will never intersect. Because they'll never intersect, we say the lines are parallel, and so there's no solution. There's no crossing of the lines. The last type of solution is infinitely many solutions. That's when they're the exact same line, meaning the slopes are the same and the y-intercepts the same. That means all along that, if you can't see it inside of there, let's see if I can blow this up. Right here, you should be able to see like the red line hanging out. It means that that red line and the blue line are right on top of each other. Okay, so these two lines are the same. We call this infinitely many solutions. That because there's a whole series of points all along that line that match up and make both of these equations true. We're going to try the following by graphing. We may need to rewrite the equations into slope-intercept form first. If I look at A, no need to rewrite. So I'm going to start with this top one right here, and I'm going to say I'm going to make the blue dots y equals 3/2 x minus 2. In this case, our slope is 3/2, and our y-intercept, or our b, is -2. So I'm going to start at -2, and with that slope, I'm going to go up 1, 2, 3, and over 1, 2. Up 1, 2, 3, over 1, 2. Once I have a couple of points, I can draw in my line. And then we're going to try another point or another equation. I'm going to call this our red equation. And our slope in this case is -2. And our y-intercept is +5. So I'm going to put a point at +5. And remember where our slope, when it's a whole number, I can put it over 1. That means I'm going to go down 2 and over 1. So down 1, 2 over 1. Down 1, 2 over 1. Down 2 over 1. I'll do a couple just so you can see it. And then we're going to connect those points. So when I look at this, I'm going to notice that both lines intersect at this point. And that is going to be our solution. So our solution is actually over 2 and up 1. So it's going to be 2, 1. I want you to take the time to try out the problems in Nearpod, and then you're going to be trying some homework.